we're here with the CEO, right?
Yes.
Of Sapien Semiconductors. Please introduce yourself briefly and the company.
Hi, this is Myunghee Lee. I'm the CEO of the Sapien Semiconductors. We do nothing but display drive IC for micro LED display.
What do you see from your customers? When do you think this will start to expand?
So this is what I see. This is my own interpretation. Like when you look at the smart glasses, there's a lot of different smart glasses in the market. So I categorize into three different types. One is just a simple smart AR glasses without display.
Yeah.
The second one is simply the conventional 2D display, like using the LEDs. And the third one is an ultimate, objective everyone is looking for. You see, this is the ultimate product we are looking for. So when we move to this end, we have to support the 3D display, also along with the higher resolution we talked about before. So this when we develop these two Type 3 displays, the architecture point of view is quite different from Type 2. So we see that right now you see the Type 1 and Type 3 is already in the market. And then in terms of Type 2, you see a more higher and higher resolution in the coming years. But I expect that Type 3 will become more available in the market in 2027 or 2028. So after that, everyone's moved to that direction.
So, I mean, even the 2D micro display, they are just emerging, right?
Yes.
This is a fast-moving market.
Yes.
So now we only have a few startups like the Even Realities, right?
Right.
Very popular. Now
Right.
the Rocket glasses, also very popular.
Right.
Then you go to the full color, which is still like emerging, right? Maybe
Right.
next year the market for that will grow a little bit. I think Rocket already announced they want to go to full color.
Right.
Even Reality is working on the next generation glasses as well. So what do you think, where can we go with the resolution for this type of glass, for the second gen?
As you know, most of the current product in the market is based on like VGA resolution with 4 micron pixel pitch. So that now most of our customer are asking a 2.5 micron pixel pitch with various resolution from 2x VGA to 6x VGA. Means that because of the AR application usually use 4 to 3 aspect ratio, so VGA resolution is kind of typical in the market. Now it's moving to the VGA to 2x VGA or 4x VGA or 6x VGA. So that's the mega trend in this end. And also, as you know, the most of the display micro display module is based on the monochrome display, mainly because of the red color issue. So in the market, in the best production is a monochrome display, but in the future, maybe 3 or 5 years later, the one panel can support full natural RGB panel in panel. So this is my expectation based on the lot of discussion with customers over the world.
Yeah, so this is like one panel, full color.
Yeah, one panel full
Everything.
color is not quite ready for mass production.
Yeah.
You will see some, technical demo or technical, to demonstration. But what I'm talking about, the mass production ready product in one panel RGB.
Yeah.
So far, most of the panel is based on 3 R and G and B panels.
But here at CIOE, I don't see this increase yet. So it's still maybe 1 to 2 years away before we see this, right?
you don't see that, but we already developed those products and deliver to our customer already. So they're gonna build it. I'm sure you will see starting next year. I have this snapshot of market what's available. Maybe based on your information, and
Yeah.
I kind of see that the average price of the eyeglass pair of glasses. So $300, $500, and $1,000. Over time, the yield will go up, and the number of manufacturing will go up.
Yeah.
So price either go down, but they're gonna increase the performance. So
Yeah.
price will, over time, price will stay same, but the performance will go up definitely.
Yeah.
Resolution go up, power will go down. So in terms of performance point of view, will increase, but price will be the same.
And do you think even in this decade we will already see the third gen?
Yeah,
Product.
I'm very positive. Third gen will be, you will see like 2027 or 2028.
Because
Actually specs, they announced they're gonna release the next year with a more like affordable
the
product.
first consumer
The
product.
first consumer
Yeah.
product. That's more like a type 3 type of product.
Yeah.
And then many front runners are preparing this high-end product, premium product.
It has
in 2
always
years.
been the end goal, right?
Yeah.
To really augment everything. Like when you see a translation of a voice, right? When we're talking and we don't speak the same language, I
Right.
want to see your speech bubble where you are and
Yeah.
not completely disconnected from you. And I mean, now the Snap spectacles, right? This generation that we see here, it still uses LCOS. But you think MicroLED can be the next solution for this?
I believe that the Alcos solution is more like a transitionary. Like I said, from the power perspective and form factor perspective, MicroLED will be the mainstream. Maybe you already investigate a lot of investment in the companies, and most of the big tech companies or major player heavily invest on MicroLED, not Alcos.
Yeah.
So I think Alcos is still, it's already mature product. So some product will adopt the Alcos product, but like a majority of the product will be LEDOS based.
The big display companies, what do you think is their role and when will they enter the market? So the Samsung, LG, but also BOE, TCL.
I think it's a AR display perspective. I think there's the big display company not necessarily have advantage over the newcomers, because the AR display is quite different from existing LCD or OLED display. Like I said, LCD or OLED display, usually they making this display based on the glass panel. But MicroLED has to, should be manufactured in the semiconductor process equipment. So it's a quite different process, flow. So there's a different set of expertise and their requirement. Of course, they have good understanding about the LCD and OLED display. However, it's not necessarily the advantage to, when you talk about the AR micro display. I mean the LEDOS display.
From what I've heard, like making the backplane is very complicated, right?
It is actually because of the pixel size. We have to integrate a memory like 10-bit or 12-bit memory bit per pixel, and then also the die size has to be minimized. At the same time, the power dissipation has to be minimized also. So those are the things require a lot of know-how in terms of how you lay out, and also you have to support many IP like image processing IP or demura compensation and so on and on. So depending on the customer's requirement, we do provide all the custom design based on those requirements.
Yeah. So you designed the backplane, right? If I understand it correctly. But manufacturing, that's a whole nother story, right?
So we are the feminist company. So we only design the chip,
Yeah.
but we manufacture through the silicon foundry, such as Global Foundry and ST Micro or TSMC or all the global CMOS foundries. Because this CMOS backplane is based on a 22 nanometer process or 28 nanometer process. This is what we are using right now.
Yeah. In the RGB glasses, like the Rainio X3 Pro, do you have like 6 backplanes in there for every monochrome display, right? So how does the backplane architecture and design change if you go to RGB in a single panel?
So basically, you have to support all RGB, graphic data processed in the one single panel instead of a separate RGB panel. So the amount of the data processing is 3 times, bigger, and also timing-wise is 3 times as bigger, so faster. So it is much complicated design. I mean, just CMOS backplane point of view, we already designed the RGB panel, CMOS backplane, but unfortunately, there's not many MicroLED supplier who can support RGB on the one plane.
Yeah. Can you, a little bit, for someone who has no idea how this is made, can you a little bit explain the process to making a backplane? Because you have like these wafers, and on top of these silicon wafers, right?
Yeah.
You build a backplane.
So
very
this
complicated.
is what I actually have like this. So we have a CMOS backplane. That's why it's just underneath. That's why we call the backplane. And then usually we call the wafer-to-wafer bonding between backplane and the front plate. MicroLED front plate is using the wafer-to-wafer bonding. This is very typical. The process technology already used for the CIS image, sensor. So once you make a bonding and cut it like this, and then you put like this one, you may have seen this kind of module already. So they make a module like this and then combine together with the prism to make a full color.
Because that's not really intuitive, right? You have like a wafer where you build the backplane on top, and then you have a different wafer where they grow the LEDs on top.
Right.
Then you somehow flip it around, and then you bond this together.
Right.
It's a very complicated, high precision operation, right?
Right. It is a very high precision process, but semiconductor process point of view, this is a very typical process.
For someone who's in the industry, that is like, well, that's how it's made, right?
Yeah.
But as a consumer, you only see the end product.
Right.
That's
Like
a whole different story.
Yeah, like I said, the CIS CMOS image sensor we have in this camera, right? This like a smartphone camera. They already use this wafer-to-wafer bonding with the sensor, image sensor, and then the driver ICs. They already use that technology.
Yeah. Well, let's wrap it up, right?
Yeah,
Thanks
thank
for the
you.
interview.
Yeah,
It's
thank
been
you.
really great. Learned a lot again. So every time here, I learned a lot, and it's really cool.
Thank you.
Thank you so much.
Thank you.